In this lesson, we're going to cover how to construct confidence intervals for population variances and standard deviations. Now, the construction techniques we use will involve what's known as the chi-square distribution. Remember, previously our confidence intervals involved the normal distribution and the student t-distribution. Well, to estimate a population variance and standard deviation, we're going to use the chi-square distribution. So to start, suppose we're given a random variable x, which is normally distributed with mean mu and variance sigma squared. Now we would like to construct a confidence interval for the variance sigma squared. So suppose that we take samples of size n, and for each sample we evaluate the sample variance, s squared. Then it is a fact that the distribution of these values right here, if we take those values s squared and construct these numbers, so we take n minus 1 times our sample variance and divide by the population variance, take these numbers, they're denoted as this symbol, that's called chi-square. These numbers will have what's known as a chi-square distribution with n minus 1 degrees of freedom. Now, we have some typical distributions shown down here for the random variable chi-square, and they depend on the degrees of freedom n minus 1. So notice that the chi-square distribution that we have pictured right here, that has 10 degrees of freedom, so in this case the n would actually be 11. 11 minus 1 gives you 10. Notice that it is not symmetric anymore. Unlike the normal distribution and the student t-distribution, it is skewed to the right. It has a tail extending to the right, like this. Now, as your n increases, the peak right here will move to the right, and the distribution of values like we have shown here for 20 degrees of freedom will become more symmetric and actually slowly approach a normal distribution. It will also spread out as the n increases. Now, to construct a confidence interval for a variance for a normally distributed random variable, we're going to follow this procedure. Suppose we're given some significance level alpha, like, typically 0.05. Now the distribution of these values, remember, will be given as a chi-square distribution like what we have right down here. So that's a typical chi-square distribution. Now, what we need to do is evaluate these cutoffs right here and right here. These are very similar to the z alpha over 2 and t alpha over 2. So these are analogous to those values that we had studied previously. Now what we want is we want the area to the left of this number under the chi-square graph to be alpha over 2, and we want this area over here to also be alpha over 2. That's the area to the right of our chi-square right cutoff. Now to evaluate these numbers here, using Excel we could type in this command right here for the left cutoff right here. Notice we would just type in CHISQ.INV, that's for chi-square inverse, parenthesis alpha over 2, comma, and then our degrees of freedom, which is n minus 1. Now to evaluate the right-hand cutoff, you would type this into Excel, CHISQ.INV, parenthesis 1 minus alpha over 2, comma, your degrees of freedom, which is n minus 1, close off the parenthesis. That will give you this number right here. Now what the 1 minus alpha over 2 represents, that represents the area underneath the curve to the left of this number right here. So that's this area, which is 1 minus alpha, plus the area in the left tail here, which is alpha over 2. So if you look at 1 minus alpha plus this area, you'll get 1 minus alpha over 2. Or you can think, okay, the area in the right tail here is alpha over 2, so the area under the rest of the distribution is 1 minus alpha over 2. Now step 2 in our process to find the confidence interval is to calculate the sample variance, s squared. So you calculate that next from your sampling. And then your confidence interval for the population variance is going to be given by this formula right here. That's it. So the left-hand endpoint of your interval will be n minus 1 times s squared divided by chi-square r. That's your right-hand cutoff under the chi-square distribution that you calculated earlier. And the right-hand endpoint of your interval is going to be n minus 1 times s squared divided by chi-square L, which is the left-hand cutoff under the chi-square distribution that you evaluated earlier. And that's it. You just have to calculate those two numbers, and that will be your confidence interval for the population variance. If you want a confidence interval for the population standard deviation, you would just take the square root of these two values up here. That's all you have to do, is just take the square root. And that's what we have listed right here. So that's your confidence interval for the population standard deviation. And that's it. You're finished. So you only have to calculate three things for these confidence intervals: your sample variance, your chi-square r, and chi-square L cutoff values. And you can use Excel or a calculator to evaluate those. Now, to understand where this formula comes from quickly, just take note of this. Remember that these values right here we said are chi-square distributed. So this interval that we have up here is arrived at by setting these values right here to be bigger than chi-square L and less than chi-square R. You see, for a 95% confidence interval, this should hold 95% of the time. So taking this inequality here then and doing a little bit of algebra to isolate the population variance symbol in the middle of the inequality, you'll end up with this. And you notice that this is our left-hand endpoint for our interval, and this is our right-hand endpoint from the interval. So these intervals come from this inequality right here, and just taking it and isolating the sigma squared in the middle. So that's where these come from. Now let's take a look at an example. Now in this example, we're going to construct a confidence interval for a population standard deviation. Now, a bottling company would like to estimate the variation in the amount of soda its machinery is dispensing into bottles. A sample of 50 bottles was taken, and the sample standard deviation was found to be 0.32 ounces. Now, we want to answer these two questions. Part A, we want to construct a 95% confidence interval for the standard deviation in the amount of soda being dispensed into the bottles. And part B, we want to construct a 99% confidence interval for the standard deviation in the amount of soda being dispensed into the bottles. Now, when we look at our solution here, you have to be careful about one thing. You notice we were given the sample standard deviation. So this value right here is actually S. So keep in mind when we apply the formula that we just covered, we're going to have to square this number to get S squared. So keep in mind that S squared is going to be 0.32 squared. That's our sample variance. So you have to be careful when you're reading through your problems whether you're given the sample variance or the sample standard deviation. Now let's take a look at the solution. Now here's our solutions to parts A and B, and we'll go over these in Excel so you see the commands that you type in. Now our alpha over 2 value for part A is going to be 0.025. Keep in mind that we wanted a 95% confidence interval for part A, so the alpha is 0.05. So alpha over 2 is 0.025. Our sample variance is 0.32 squared, which is this number. Our degrees of freedom is 49. That's 50 minus 1, remember? Now using Excel, we can evaluate the left-hand cutoff, chi-square L, to be 31.55492. That's using this command right here. Notice this is alpha over 2 right here. And the 49 is your degrees of freedom, 50 minus 1. We can also evaluate the right-hand cutoff, chi-square R, to be 70.22241. And that you get by typing this command into Excel. Notice the 0.975, that's going to be 1 minus alpha over 2, where alpha over 2 is 0.025, and the 49 is still your degrees of freedom, 50 minus 1. Type that into Excel and you'll get 70.22241. And from there, we just need to put all of our information into our formula right here for the confidence interval for a population standard deviation. So the n is 50. So 50 minus 1 times our s squared is this number. Chi-square r is this number. So the left-hand endpoint comes out to be this right here. The right-hand endpoint is the same as the left-hand endpoint, except we replace chi-square r with chi-square l. And we get this right here. Evaluate both of these on your calculator or in Excel, and you get this as your confidence interval. Now remember, that is a confidence interval for the population standard deviation, sigma. Notice also that we rounded it to 3 decimal places because we were given that our sample standard deviation was 0.32. That was given to us with 2 decimal places. Now for a 99% confidence interval, it is the exact same procedure as up here, except we use 0.005 for the alpha over 2. That comes from the fact that for a 99% confidence interval, the alpha is 0.01. That's 1 minus 0.99. And so basically, to find your left and right hand cutoffs, you replace this with 0.005, like right here we have, and you replace the 0.975 with 0.995. That 0.995 comes from 1 minus alpha over 2, where alpha over 2 is this number here. And so you will get these 2 values for your left and right hand cutoffs. And then you just have to plug all your information in this formula right here. So the left endpoint of your interval will be the square root of 49 times 0.32 squared divided by 78.23071. And the right-hand endpoint of your confidence interval will be the square root of 49 times 0.32 squared over 27.24935. And you get this interval right here. Now notice, of course, this interval is wider than this interval, as we would expect. Note 0.253 is smaller than 0.267, and 0.429 is larger than 0.399. So this interval is wider, as we would expect a 99% confidence interval to be wider than a 95% confidence interval. Now let's take a look at using Excel to calculate these, just to make sure that you can type in the correct commands. Now let me show you how to enter all this information into Excel and a few tips on evaluating the confidence interval using Excel. So for the chi-square inverse that determine the left and right hand cutoffs, we can just enter them like this. So we select chi-square inverse, put in our parameters, there we go. That's this command right over here. And when we hit enter, there's that value 31.55492. For the right hand cutoff, and hit enter, and there's your value 70.22241. Now when you're evaluating the left and right hand endpoints for your interval, to avoid round off error, you can enter them all as one Excel command like this. Watch what I type. So notice how I have that entered as one Excel command. Notice it's the square root of 49 times 0.32 squared divided by chi-square r. And then when we hit enter, there's the value 0.267. For the right hand endpoint, we would do the same thing, but replace the chi-square r with chi-square l. Now watch what I'm going to do. Instead of retyping this entire command over here, I'm just going to copy it over. So I highlight this, hit Control C, move over here to this cell, hit Control V. Now that's the same number. Now watch what I do. I hit F2 to edit it, or I can go up here and edit from the command line up here, but I usually just like to hit F2, and I can just change the 0.975 to 0.025, and there you go. There is my right hand endpoint, 0.399, and that's the value that we have right over here. And then for this interval down here, the 99% confidence interval, all we have to do is change the 0.025 to 0.005 and the 0.975 to 0.995. So watch, we'll do that. I'll leave these cells here. I'll copy them. I'll highlight them and hit Control C. Move somewhere else. Hit Control V. And now I'll just edit these. I'll hit F2. Change the 0.975 to 0.995. And then go over here, edit this one, change the 0.025 to 0.005. And there you go, there's our interval that we have right down here. That's our 99% confidence interval. And so that's how you can use Excel to easily calculate confidence intervals for variances and standard deviations.